Um, just to confirm, can you guys hear me?
Yes, sir, we can hear you.
Yes, sir.
Perfect. Okay. Um, can you see my screen over here? I think it's
Yes, per
a you.
mesh contact ratio.
Yeah, perfect, man. So, guys, I just thought I'll share this with you. I highly recommend checking this guy's channel out. This Drivetrain Hub. It's got some cool things for gears to obviously accentuate your understanding. Um, I was thinking of even this one over here. It's fairly good as well. Talking about the contact ratio. But I just wanted to play this video and you can actually see something, right? So I'm just gonna play it. And okay, let me explain to you. So obviously this is our it's length of approach, the length of recess. This is our essential that this is the line, but obviously you guys in this particular in the textbook you guys don't see it like that. But anyway, this is the length of approach, and obviously we all looking at the contact ratio. So what's cool of this thing what he has done on the right hand side, you'll notice that there's mesh cycles and there will be this contact ratio over here, right? Obviously, this is what's important to us. We have established that the contact ratio is amount of pairs of teeth that are in contact, right? You'll notice there's two graphs, will be the transverse and the axial. And when we look at helical gears, and I should actually put it up there, you'll notice there will be an actual contact ratio as well, because the gears are the gear teeth are at an angle and they kind of slide one over another. But nevertheless, in this case, we only have a transverse move for spur gears. And as I play through the video, you'll notice it goes through different cycles, but there'll at least will always be one pair of teeth in contact. So if I click over there, but a contact ratio of 2 at that mesh cycle, you notice that's in contact over here. And you guys see that 1, 2, and as it goes over here, we have one teeth in contact over there. Can you guys see that? So that's what the contact ratio is about. Are we all happy with that? So I just want to stop it somewhere around. Okay. Can I stop it around? Could we all see that?
Yes, sir.
Yeah,
Yes, sir.
cool. So at 1.6, you'll notice there's one and then there's like a slight. Yeah, cool. So that'll just give you a visual representation of what you're actually calculating. And obviously these yeah, these when you calculated this, surely that equation is on that side over here. This looks like an Excel spreadsheet. Not sure how he's actually managed to get this down, but nevertheless, very cool channel. You'll notice even when we do the helical as well, the contact ratio for the helical, obviously be useful as well, and a few other ones as well. But nevertheless, I thought I'll share that with you so you can actually understand what it actually means. Let me just admit. All right, let's quickly revert back.
Oh, sir, can I ask you a question?
Yeah,
So,
sure, definitely, man.
which gears are we gonna be focusing on? Is it spur gears and some
Just
spurs?
hold on. Someone's talking there. Okay, cool. Just Banili, you're saying?
Yes, I just wanted to ask which gears are we gonna cover? We're gonna cover all of them, like spurs
So
and
Spur and helical, definitely.
okay.
If not after that, it's gonna probably be Bevel. But focus on Spur and helical the most.
All right.
Yeah, that's definitely high priority. Um, and then depending on the time, we will squeeze in helical, I mean bevel. But the four main gears which one should master is spur, helical, bevel, and the worm gear. That's basically it. The next chapters after this would probably be the brake clutch stuff. That's what we're going to end off with. But so we're nearly there. And you'll notice with the gear stuff, it's fairly the same, just different formulas. It's the same concept, but just different formulas. So
Yeah,
yeah,
because the gears are they operate in like, or they shape differently or something. Yeah.
yes, exactly.
Yeah,
Because the
so
geometries are
that.
different. Yeah, you'll see once you do it. It seems a lot, but it's actually quite chill.
Okay. Thank you,
Yeah,
sir.
yeah. So if you want to work it, make sure you understand Spur chapter, the helical as well, and then of course go on the clutch and brakes. But we'll share that notes eventually.
Okay.
Yes. Okay. You have a question, Louise? Or you Mikey just mute. Okay. What am I sharing now? Slides, right? Is it correct? Am I sharing a
Yes.
slide now? Okay, cool. So I'm just going to recap quickly on this. And I want to make everyone aware, please, 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 please. What I'm doing right now is of critical importance, right? So what I recommend is you really pay attention, you really take this seriously because this is gonna come up somewhere. And so your understanding of this is of only to your benefit for the subject, right? So anyway, we have this force through that contact, right, through the gears of mating, which is a pitch point. That force Fn gets split into two components, which is your tangential and your radial. The tangential force is the one producing that torque, that force times the radius, and your radial force is the one separating the gears. Obviously, we looked at this very briefly. I'll tell you what is important over here. So we have two gears mating, one pinion and one gear, or drive and driven. The force, what you are seeing here, right, is the force that the pinion is generating on the gear, right? So it's pushing, as it's turning, it's pushing it away. And then that PT force is that force responsible for turning that thing. Right? Obviously, the resultant of the two would be that PN. And then that's what you're seeing over here is the force generated by the gear, the driven on the driver, which will be the radial force. And then, of course, now I'm just finding why they didn't put because normally I'll have it a bit differently. This PT will go in the direction of, okay, anyway. So this forces you see here is the force generated by this gear on that gear. So you understand why this is important when we are obviously looking at what is this? The next part. Okay, so we've looked at that. We've talked about this. We did Milo helped us nicely with this. We found did a basic example of the forces on the gear. And now we're going to do example 11.5, which is of great importance. So what I'll do as well, I'll send two questions. They're from two different textbooks. And they have solutions. And so make sure you go over them and understand them very well. Yeah. Obviously talking to this particularly. So when I'm saying this is important, guys, make sure you are going over this profusely. Even the stuff after this is super important. And you understand why. Nevertheless, here we have three meshing gears, right? We could have actually sketched this up and see what it looked like. They have a module of 5, pressure angle of 20. I'm going to show you something about explaining that gear teeth as well. Yes, someone said something. Was that a mistake? Okay, cool.
So can you accept the students who are out?
Okay, yeah, I'm accepting them now. Yeah. Can't you accept them?
No, I can't, sir.
Oh, okay. I thought maybe normally I didn't. Okay, I'm accepting them. Don't worry. Thanks. So over here, right? So then we have gear 1, which is driving gear B, and then gear C. Obviously, it's 40 kilowatt at 2000 RPM, right? That's going to help us to an idler gear, right? On shaft B, but an output gear at shaft C, okay? Which drives whatever machine you're driving. And then they're asking you determine and show free body on a free body diagram, the tangential forces acting on K2. The main word I'm trying to bring across there is the word acting on K2, right? So don't get confused regarding that. And then what I want to I was going to share something with you as well. And then they also want the reaction at what is this on shaft B, which is basically on that. And then what is important here, they say an assumption, the idler gear and shaft turns transmit torque from the input gear to shaft torque to I'm missing some text there. Let me just get the proper text there. But what that is saying there is that the idler gear has no torque. So the idler torque, yeah. So it's directly going from obviously the first gear, right, to the output gear, and then just wanna the text is there, and let me just get it down for you. Yeah, I just wanna make it a bit smaller. I'm gonna use this image now. Cool, just copy it so long. Yeah, so the idler gear and shaft transfer power from the input to the output. No idler shaft torque is applied to the idler gear. Yeah, so there's no shaft torque. And then friction losses in the bearings and the gears are omitted. So we're not looking at any losses in terms of our transmission over here. Obviously, there's very small losses. These systems are fairly efficient. And yeah, okay. So let's try to attempt this one, right? So I'm going to copy it on the OneNote and we're going to solve. Plan to solve at least this one, and then there's another one as well. But in a subsequent subsection. Okay, why can't I move this now? It's in the wrong place. Okay, so I'm just give me a minute, then we can begin. So again, this gear here, it's an idler, right? I don't know if you guys are familiar with what that is. Okay, cool. Just wanna. Okay, cool. I'm gonna share OneNote now, so you can get out. Why can't I paste this over here? There we go. Cool. Let me just share, and then we can begin. So remember, there are three forces. I'm gonna accept this student in as well. Okay, cool. It's done. Yeah, there we go. All right. Can we guys see the OneNote? My question, can you see the question over there?
Yes, sir, we can see the question.
Perfect. All right, so let's go to begin. So the first thing we probably want to look at, I wanted to do these free body diagrams before we actually start putting values on anything, right? So what I'm going to start doing over here, and I'm going to be very deliberate. I'm sure I have a shape here, and then we can do another shape over here. Okay, cool. Can't you look like a circle? Okay. Let's now rotate. See if I can. Okay, it's not going to pick up. Choose a circle for us here. Perfect. That looks like a circle. Okay. So let's see. So the first thing maybe you want to possibly do here, guys. So the direction of this guy is clockwise. What's the direction of this one over here? Of the idler one, number 2. Can someone tell me?
Clockwise.
Clockwise, right? So it means going this way. And this one over here. Gear number C. I think I heard someone say something.
Anti-clockwise, sir.
Okay, seems like Milo's the only guy who's here, huh? Right? Milo, how do you know this? Is this by logic or were you taught this? What you guys taught this?
So I'm looking at gear 1, it's turning anti-clockwise.
Yeah, I'm not sure if people are aware of how this works. Don't bother me if they don't. Yeah, okay. Cool. So that's the first thing. So let's try to analyze each individual one over here. So we have this guy turning this way, this guy turning this way. So I'm gonna use I use black and then I'll use red. Okay, let me just, where am I now? Okay, cool. So like I said to you, as on this gear, right? So it's turning this way. So we're gonna have the one force which is doing this. That's my FT, right? And then,
Sorry, sir.
yeah,
I'm not sure if I'm the only one here who can not
not
see
see.
what you're actually drawing. Yeah.
Yeah. So you gotta
It's
refresh,
not-
man. You gotta leave and come back. Yeah, if that's the
Okay.
case. I'm assuming that everyone else can see.
No, so yo.
No, I also can't see.
Ah, guys, man, I didn't ask you. Okay. Oh, you saw the question. Oh, I see. Can you guys see it now? Thanks for that.
Yes, sir.
Okay, so can you see the direction over there, right? Oh, yeah. Are we happy with the directions, huh? Is everyone content with that? Yeah.
Yes, sir.
Okay, and I'm over here doing the forces now, right? So this gear A is turning, so a tangential force will go in that direction, I believe. And then you have your radial force pushing. So what's important to note of these forces here, the black ones, this is the forces which is acting on gear 2, right? So that's from gear, yeah, we're going to say acting from 1 to 2, right? There's different ways you can write this down. I see that the book uses a different notation. Yeah, but this is the forces where 1 is acting on gear 2, right? So then if you looking at this gear now, this gear will also have a force, but you'll notice it's nearly the same as the other one, where it's turning this way. So the tangential force is that way. And guys, always remember the radial force is always splitting. Let me just get the slide. Sorry, guys. The radial force is always pushing against something. Yeah, that's always separating the gear. So you always know the direction of the radial force that's pushing away. Yeah, that's what I want to say. So now, if I come to this point over here, now, let me add the next gear. And if you remember the question, it states it wants, oh, where is this now? Okay, why you red now? Let me change the color. It's looking for the forces acting on gear 2. So that's very important. Okay, cool. Let me just, yeah, get this one now. Okay, yeah, it looks something like this. So in this case, here we have this here is turning this way. This is the forces acting on the red forces here. So obviously that's also FT. It's always the same, and then this will be your FR, right? So FR is always separating the gears, and that is going to be the forces of gear 2 acting on gear 3, which is it's not that we don't need this yet, right? And then this is turning this way, right? And now we have to include that forces, and then that is turning that way. We can have a force like that in the opposite direction. I think it's kind of obvious, and then another force going that way over here. So this will be FR and FT. And those black forces are the forces of gear 3 acting on gear 2. I could have done the same over here, by the way, but I didn't think that was important at this particular time.
I think gear 3 is supposed to be the other way.
It's the other way, no? Let me just quickly check. You're talking about the forces.
Also, the red arrow.
Direction.
Oh, yeah. Thank you. I see it now, yeah. So it's turning the other way, therefore it's going. How do should I say this way, no? Is that fine? I hope you all can. Yeah, there we go. Cool. You can see that. Yeah, it's going.
No, sir. Isn't it supposed to turn anti-clockwise? Because
Yeah, it's
the other one is
anti-clock.
turning.
It's anti-clock, Milo. Can you see there? This way.
Oh, no.
Check. Let's come back here. This is going
No, that one is
Oh.
the
Anti-clock.
clockwise.
So that's
Okay.
clockwise.
Okay.
That's-
Okay.
Oh, that is the big one is supposed to be clockwise.
Yeah, I see. Okay, yeah, let's do this again, man. So this guy on top is anti-clock, right? Am I right?
Yes.
This one
Gear
is
1 anti-clockwise, gear 2 clockwise.
Clockwise.
No, clock.
right, and this one is like this. Are you happy?
No.
No.
No,
it's supposed to be.
we're not there.
So gear. What is this gear?
Clockwise. Gear 1 is anti-clockwise, right?
Yes.
Okay.
Yes.
Then
Gear
this
2
is
is
gonna be
clockwise,
clockwise.
therefore C will
Yes.
be clockwise.
Then
And
gear
this
3
one?
is going to be anti-clockwise again.
Which is this way, right?
No,
No,
the other way.
This way. Is this clockwise or anti-clockwise, guys? Why are you guys getting confused?
Oh, I see. No, we're confusing you, sir. Okay, I see.
Yeah. Is it not this way?
It is.
Yeah.
It is. No, we're confusing you. Sorry.
Yeah.
Sorry. Sorry.
No, it's fine. No worries, guys. It's good. We need to go through it. I think it's that way, right? Yeah. Are we happy with this now? You know what's going on? Is it no? Which way is
It's
it?
not. It's not.
It's supposed to go the
It's
other way.
not.
sir.
This way.
Clockwise.
It's going this
C
way.
is supposed to go
Yes, there we go.
Yes.
When you,
Because now they're going the same direction. B and C are going the same direction, according to your arrow.
So that means you're saying this one is going like this, right? Like this and like that.
Yes.
Yes.
Yes, and this one is going like this.
yes.
Yeah. Okay, here we
Yeah.
go. Yeah. So cool. Let me see here. Would that change our forces now? Why am I okay? Let me just see something here. Let me just check something. So wouldn't that change our forces?
The red one will stay, the black one will go.
The red one will stay. Yeah. Okay. Cool. Okay, just. So this one is going like this. This one is going like this. That one's going like that. Is this two going in the same direction? Yeah. As long as these two go in the same direction, that is correct. Yes. And then we have the radial force I'm missing over here. Okay. So cool. I think we have this now. Just want to see something here. All right. So I think that's cool. So I think we have all our forces. I forgot about this one here. It went away. It's FR. These all our forces on this particular gear over here. So we have the forces on here. So guys, always make sure you check. Yeah.
The red forces were supposed to stay, the black ones were supposed to go. That's what I meant. Isn't it the force supposed to be
So
downwards?
we're looking for the forces on gear 2. Okay, so the question was. You got me. It's
Yes,
on
sir.
gear 2, not on gear 3. So what forces are
Okay.
these one generating on this one? What forces of this one generating on that one? You got it. Not generated by gear 2, on gear 2. That's what I was trying to bring up the whole time. Are you with me?
Yes, sir.
Yeah.
I think I don't seem to be getting it.
CK, we can barely hear you, my man.
I am saying that FT going up, it doesn't make sense.
F3 going up doesn't make sense, right? This is what I was saying. These forces, these. Okay, let me do this. Let me do this. Let's unpack this. These directions is the problem. I wanna check something. Where is my? Because this is what I'm saying, that if this is turning this way, that means FT will be going this way. You see what I'm saying to you? FT will change. Exactly. Based on this. This is what I was asking. And that's the right logic. But I'll show you something now. Let me just do this for you guys so you guys can see these rotations. Just wanna I did share some links with you guys, no? Just check. Did I share some links with you guys regarding gears and stuff? I did share it, no?
No.
On Blackboard, sir. Wait.
Yeah, it's on Blackboard. Where we can put up some gears and stuff.
I don't think there's any on here on Blackboard. This stuff, look.
Yeah, I think it's the MG Virtual. So one, I'm opening it now. I'm gonna see, because I think this direction is getting you guys here. Let me see if I can demonstrate this using some virtual thing. How do I shift these keys now? Okay.
I don't see any links on the design of gears section.
Yeah, I'm thinking now if it was on the man. Yeah, I did show you guys some stuff. Did I not post it, I think? But it's fine, man. It's fine. Let's not.
You posted links on bearings, but not gears.
Yeah, I think I didn't actually post that. But let me just admit that guy. Then we'll move on. That's fine. It's fine. I'm just gonna try and see if I can show you something. If I can see over here. Okay, cool. Let's get back here. So if I go back to the question, let me just see here. This rotates that way. This rotates this way. That rotates that way. And if that is the case, then we're saying our FT must go this way, right? FT is that way. Then we have our FR being that way. Now this, let me just check something here. That's FR. This is FT. This is what Sikho was saying. That's what I was saying. Don't our directions change. If you're looking at the forces generating, now you see my concern with this, right? Okay, that's fine. Is that these forces should be all opposite and equal. Because if this is going this way, I think this should be going clockwise, and this should be going anti-clockwise, right? Clockwise, anti-clockwise. I'm thinking, anyway, fine. So if this is the case, let's try to find our gear forces. Yeah, okay, they seem okay for now. We're gonna see. So let's start in gear one. This gear one was given, and here they give us the torque. And so from the torque, let's compute this over here. P equals 2 pi P60 2 pi N. From our torque, we then can obviously use our newfound equations, if you guys remember them, to find all the other forces. So we know that torque is also equal to Fn cos theta. And then obviously it's by d over 2. But if you remember that Fn is basically, that force over here. Let me just come over here. The one over here. That's essentially it's equal to Ft. So Fn is equal to Ft, by the way. I'm just making you aware. That is Ft. So let's quickly get the torque first now. All the values should be there. Let's get the torque. Sure, you guys can do that quite easily. Just see, something is bothering me big time. Okay. Okay. Let's get that torque.
Yeah, the torque is 190.98 Newton meters, sir.
Okay, 191.
191.
Okay, 191, right? Perfect. We can call 191, no problem. So can you please mute your mic there? 191. That's fine. You can call it that.
Okay, I'm not going to come on. Give me like 5 minutes.
Yes, thank you, Aluve. Thank you.
Oh, sorry.
Fn is equal to 191 Fn. You could have found Ft immediately. It's entirely up to you how you want to do this. Cos pressure angle is given, right? Of 20 degrees. Perfect. And then, of course, we need to now find, how do we find our diameter, guys? So we have, how do we find the diameter now for this guy? So we've given him the amount of teeth. So I'll just recap for you guys. So your module, remember, is your pitch circle diameter, your PCD, divided by the amount of teeth. That's what it is. That's what the module is. Very important ratio. So obviously we don't have to call it the PCD, but you can just call it D. So you have the module of each one, you have the amount of teeth. You can easily find the diameter for each one. So I'll just leave it there. And you can compute F N for me, or Ft you can find immediately. Yeah, different ways you can do that. There's many ways you can find this thing, by the way. In fact, if you don't want to find Fn, this can just be Ft, right? Like I said, let's just call this Ft. Yeah, you can erase this. We can call this Ft. Remember that tangential force is the force which is producing the torque. That's d over 2. You see what's bothering me about these rotations, man. It's bothering me. Big time. Front. I'm just doing something quickly here. 5 and then
So
yes.
for the direction of gears, I think
Yeah.
we can what was I gonna say? I think there's a method or a golden rule maybe we can
Okay.
use to
Yeah.
note that direction. Like for example, like if the number of gears are odd, then the first
Yes,
gear's direction will be opposite to the last gear's direction.
that's correct.
But if they are like even, yeah, but if like the gears are even number, then they will be at the same direction, the
direction.
last gear and the first one.
That's correct.
Yes, if they are even.
So if they're not even, right? The gear is going this way, right? Is it not so? In a different direction.
Yes, they'll go opposite direction. Yes.
Yeah. Right? Like this. Because this one is going this way, right? Is it not so?
No.
Yeah, it's going
Yes,
that
sir.
way.
Yeah.
Yes, sir.
That's what I'm saying.
It was like this before, sir.
Before, like the one I had. Yeah, that's what I'm saying. This is what I'm understanding. So you guys are saying that it's going the other way. You guys are saying it's going this way. Remember? That's what you guys are saying. Yeah.
Yeah, I know, we confused you. Yeah, we're confused.
Nah, you child me, man. You child me. I was like, what? Which way is it going? It's going this way. This one is going this way, makes that one turn this way. And if this one turns this way, that one turns that way. Is it not so? Yeah.
Yes, sir.
Okay, cool. Yo, man, I was thinking now, something doesn't make sense, man. And I'm just checking here. We're gonna check
I
something
think
now.
there's. Do you mind if I sort of just say,
CJ, we can barely hear you, man. That's a problem. Your mic or something is.
how about now? Can you hear me now?
Yes.
Yeah, you are talking about the two gears, the one on top, a big one and a small one. Looking at those gears, they are going in the same direction, which is clockwise. That's what I'm saying. They're both heading the same way.
Yeah.
So you are saying that's how it's supposed to be.
Like this.
Yeah, because they are going clockwise.
Okay,
both of
just
them.
you'll come back to the directions now. Don't worry. I'm pretty sure this one is going this way. Anti-clockwise. This one is going clockwise. This one is going clockwise. This one is going anti-clockwise. I'm gonna show you now, but let's just quickly get the values and then we're gonna move on. We'll come back to the directions now. Don't worry about it. Sort it out now. So what is my diameter for gear one? Let's get it. Using that formula. What is D here? We just need this. We'll come back to that now. Let's just get the forces quickly.
I think FT, I got like something like 3820 Newton.
Sorry, what did you guys say? FT is what?
3820. Obviously, I first had to get.
You said it's what? 3? I can't hear you.
3820. 3820
Okay, perfect.
Newton.
Okay, that's Newtons.
Yeah,
That's fine.
doing that, obviously, I
Okay.
utilize the module G, which is equal to D over N, G1, which is what I'm looking for, and the N1 is given as 20. So I sort of just multiplied. I came up to 20 times 5. That is the module. I get a diameter of 100.
A diameter of 100, no? Okay, it's fine. Yeah, that's fine. Okay. 100 millimeters.
190.
That's fine.
Yeah,
So that should be
191.
0.1. And then our other force is a radial force, right? So FR is given as, there's another approximation of FT times something, what was it called? FT10. Yeah, FT10, the pressure angle. So we can get our radial force. So it's FT. I hope you're understanding at least the forces. It's important, no? Okay. So we can just get this one. We're going to need this one. And you'll come back to this direction, which is showing people here. I just want to see if I can do something. Okay, yeah, just get that thing for me quickly as well.
The value of FI is 1390.
1390. Perfect. Okay. Colleagues, just please corroborate the other colleagues' answers before we move on.
Sir,
Yeah.
I just sent you a video on WhatsApp which explains the direction of gears. Probably
Okay.
would be understandable for the other students.
Okay, cool.
Yeah.
But you agree with my directions there, or
Yes, I do agree. I do
yeah,
agree.
yeah. Oh, that's
Yeah.
beautiful, my man. I love it. Beautiful, man. I can really see. Yeah. Yeah, it's beautiful. Okay, perfect. I'm gonna compile a list of nice videos for us to watch. Yeah. That's probably you may share that, and I appreciate that, man. That looks good. I'm actually just doing something as well, but I'm just getting it right. But I will share some links. Don't worry. Okay, cool. Is everyone happy with the forces? The torque, FT, and FR. Do we all get this?
Yes, sir.
Perfect. So let's quickly show you. I just want to show you this, and then we can get back to the question. I think Milo just left. Put it back on again. It's cool. Yeah. So I'm gonna say I thought I sent you guys these links, but I think I didn't actually end up. So yeah, I've used this over here as some kind of simulation. I didn't put it exactly the same. Let me just check here, man, because I was in between. Yeah, so this gear 3 must be where? Is it 180 degrees, no? Okay. Gear 3 is 180. Where's 180 now? Where's that gear now? Okay, let me just say 90. For this guy, this is at 90. No? So that's how I play around with these things, man. I just found it the other day. Okay, cool. But let's just use it like this, right? Cool. So can we see that this gear 1, when we're calling, is going what? Anti-clockwise, right? Can you all see that? And the gear number 2 is going clockwise, right? And then this gear is going anti-clockwise. Can we all see that? This 2 is going the same direction.
Yes,
Yes,
sir.
sir. Gear 1
Yeah.
and 3 are in the same direction.
Yeah. And so if we're going to be fancy, and I think that was Team now or Bandile said, if we do even gears, man, let's put it somewhere. Where can I put it, man? Reference angle what? Let's say, I'm not even sure. Let's say 270. Yeah. Can you see that this gear is going clockwise? No? Is it going clockwise? No? Yeah. So one of your theory was true. Can you see it there?
The blue one.
Yeah, it's going clockwise. No? Yeah.
No.
Anti-clock.
It's going
Anti-clock.
anti-clockwise.
Anti.
Yes, sir.
Yes,
No,
it's going
man.
anti-clockwise.
Yeah.
Yeah,
Let's check.
In what direction does a watch tick, analog watch tick?
So the first gear is going anti-clockwise, no? Can you see that? This way.
Yes.
Yeah, this guy's going this way. No?
Yes.
This one is going this way. Right? That way. And this one is going this way. I don't know if my mouse is making any justice.
No. The small gear, which is the blue one, it's sort of like
Clockwise, man. Oh, I think people are seeing it all differently. You can look at it different ways, no? It's crazy.
Yeah,
I'm seeing it now. Yeah. But okay. So I'm gonna send you this, play around with it as well. It would have been a cool app, no, to do. I'm realizing now. Let me write this down. Okay, cool. That's a pity, man. Maybe we must. When I see you guys on campus again, we'll talk about this. But anyway, let's get back to the fun stuff, the unfun stuff. So let's quickly solve that question. It's always a good exercise, these things. Yeah, okay, cool. So what's key is understanding the directions, and then of course we establish it's going this way, and FT must be that way, right? So let me just put it this way. Okay. Let me just erase this, guys. They don't want to do that, but now I'm ending up with this. No, okay. I'll just do it like this. FT is that way. So FT is going this direction. I'll just re-sketch it for you here. It's a bit uncomfortable, but you get used to it. Anyway, fine. So they want us to, so we've established all the forces acting on gear 2, which is this one and that one. Now, the way they write it is like this. I don't care of the notation of how I write it, but we know that F R, which is acting from gear 1 to gear 2, and FT acting from gear 1 to gear 2. We found out that already, and FR is 1.39 kilonewton for the sake of ease, and FR is going to be, other way. FR is 1.399, and then FT is 3.82 kilonewton. Cool. So we've done that already. Then we want to check FR from gear 3 acting on gear 2, and we want FT, which is acting on 3 to 2. And what's key here is, again, the gears acting on gear 2, right? If that is the case, if you're looking simply at these ones over here, so if the forces which is going to be transmitted within gear 2, from gear 2 to gear 3, you'll notice it'll be FT this way, right? And then FR that way, right? So FR is always pushing the gears apart, which is in opposite and equal magnitude to these ones over here. Can you guys see that? So that means that red FT, I'll do it like this for you. I'm looking at the red FT is essentially equal to the red FR. Hope you guys can see that based on the sketch here. So you see, I'm obviously this is that there. So just it's a bit messy there, right?
Wait,
so
I'm a bit confused.
Okay.
Now. So
cool.
With the red ones, what do I want to ask?
So I can talk you through it.
Are the red forces
is
from gear 2 acting on 3?
That's correct. And obviously the equal and opposite is happening on gear 3 to 2. You got that, Bandile?
Okay, so the black one is 3 to 2.
Yes.
Okay.
So, and obviously there will be equal and opposite, am I correct? So can you see FT is equal to FR and FT here is equal to FR there?
Yes, sir.
Yeah, cool. That's what's key there. Yeah, it tripped me up as well the first time when I redid this, man. It's painful stuff. So that's for my FT, and then for FR, it's gonna be for that FR which is going up. And you don't have to do all these unnecessary labels like me, man. That FR, the black one, is equal to the black FT. But I'm being very deliberate on the red FT. so that when you rewatch the videos, it'll be easy. And these are the same. So obviously this is also equal to that. I mean, on this end, this is like this. Therefore, that is like, sorry, it's other way. Okay, let's do it like this. Anyway, so that means the FR here is the same. So the I legate. So FR over FR is equal to FT. So FR here is the FT over here. Okay. Okay, cool. So super confusing. So that case, my FT should be for this one is 1.39, I think. This one is 1.39 kilonewton. Am I right? Yeah, is that one? And this F, the one going up, the black one is 3.82 kilonewton. Cool. Yeah, so that should be. Is it my FT 3.82? Yeah, man. Yeah, I'm just checking let me just check the book. It seems like I'm kind of right. I think, check my note here. So it's 1.39 against 1.39. Yeah, it's fine. And then, okay, that seems cool. So once this is done, okay, I think that's all of them. The 130 action at shaft B, which is over here. It's just over here. Obviously it's somewhere over there. So it's quite simple. To find the reaction at shaft B, I'm just going to do it like this. FB, it's just the sum of the forces in the X plus sum of the forces in the Y. And if I take that on, obviously, squared, it's the resultant. Okay. And then let's do like this. And let's do like that. So the sum of the forces here is that we have, in the X direction, we have, is it FT and FT? And then we have, let me see, and then my FR must equal my FT here. Okay, yeah. Okay, fine. So we have, just take this away here. Okay, cool. Just want to make sure all my stuff is right here. So here we have, okay, let's FR is gonna be Y, this guy is gonna be X, this guy FR is X, and this guy here FT is Y. I hope you guys can see that over here. I messed up with these signs, you guys. Sorry, man. I'm realizing now. This here, that this is supposed to be FR, and that's FT. This is the same thing. So what we do, we're adding up. Obviously, you have to take directions into consideration. So in the X direction, we have FR 1.39. 3.82 and a 1.39. So I'm talking about that one and that one. So FR and FT, they're both negative, right? So we just can add them up basically, or negative. So FR minus FT, I'm saying this one here, right? Negative. I'm putting the signs there for you just so you guys can also see. I could have put it in front as well. So we're just going to take the sum of those ones, which is negative 3.82. I believe everyone is following, and 1.39. And then if I look at my Y direction, it's going to be up So it's up and up. So it's FR plus FT, which is this one. FR is plus, and that's also plus. So it's basically the same value. So it's 3.82 plus 1.39. So can I get my reaction there? Obviously, you can find direction as well. Let's just get the reaction there, and then we're basically done. Let's just get the reaction. Yeah. So I just want to make a note as well, because I didn't realize I didn't put the links. I'm sure I did, man. Just check. So can I get my reaction, please? Oh, okay. Aiden, Aluve, Annelisa, Lucio. Okay. Cool. Guys, get the reaction.
Yes, I'm getting a 7.37.
Okay, let me check. Yeah, that's correct. Yeah, 7.37.
It's like 7.4 on my case.
Yes, CJ?
Around there. 7.4, around there. Yeah, so
Yeah, it's fine.
yeah.
37 is fine. Okay, that's cool, guys. Hope everyone has learned something here. Obviously, I always recommend the first point of study. Yes.
Oh, sorry.
Okay, yeah. The first point of protocol is go over the video. And then obviously, once you're done with that, tackle the questions. I want to show you. I want to do one more thing, but I will keep it for when I see you guys on. So when we're starting designing the actual gear. Is this particular thing. I want you to go over and like guys, make sure like 100% go over these things without fail. You can come to this one next. Can you see my Word document? You see it over here?
Yes, what is
Yeah,
Spur
so
gear forces?
yeah, go over this one. The solution is from Shigley's. Then go over this one as well. Then some solutions as well over here. So go over these two, and then go to the textbook and go play around. You know what I mean?
Wait,
For
are you
those
gonna send us this document or should we
Yes,
look
that's
for the
correct.
ones in the-
Yeah, I'm
Oh,
gonna send you this one. I'm sending you this one.
okay, so
Yeah, and obviously go to the. If you go to, yeah, there's a few of them here. I mean, if you mastered all of these ones, man, you honestly fine. I can assure you that. Yeah, and then we'll continue with the sections here. This is the Lewis and Buckingham. That's the next pieces, and then we'll do some of the AGMA bending strength and the wear strength. That's the next part. Then you're applying that to helical, might squeeze in bevel. Okay, I'm still sharing the other document. Yeah, but anyway, just go over the ones in the book as well. You should be covered there. Yeah, so I'll send you guys once I've got the recording, put up the link. And then, yeah, we'll be sorted. But I think for now, we're moving quite fine. And I think by next week, we should be done with spur gears. Then the following week, we should be doing helical probably for 1 week. and afterwards it's brake and clutches. Cool. Guys, thank you very much. Please practice and put fire in the project. And if you have any questions on the projects, just email me. And then make sure you get at least a distinction for the project. That's 30%. The midterm, I think you guys will be fine, I can assure you. But we'll talk about that once I see you again. Okay, guys, thank you very much, and see you on campus next week.
So can I ask?
Sure, you can ask, man.
So I just want to ask, FT122 is equals to